번째 특별 강연부터 여러분께 소개해 드리겠습니다. 뉴질랜드의 소프트웨어 교육은 어떻게 이루어지고 있을까요? CS 언플러그 연구팀의 케이틀린 던컨 님께서 함께 해 주시겠습니다. 여러분 큰 박수로 맞아 주시기 바라겠습니다. It's my pleasure to invite to the stage Miss Caitlin Duncan. Thank you very much.
Kia ora, hi everyone. My name is Caitlin Duncan. I'm from the University of Canterbury in New Zealand, where I am a part of the Computer Science Education Research Group. And first I want to say thank you so much for having me here today. It's a real honor to be a part of this forum. It's been really exciting so far. So today I'm going to talk to you about computing and digital technologies education in the New Zealand curriculum as it currently is. So in New Zealand, the name of the subject which covers topics of computer science, software engineering, and programming is called digital technologies. And at the moment, it encompasses computer science, programming, and software, but doesn't really cover computational thinking in the exact curriculum. And at the moment, we're working to change this and bring in new subjects. So digital technologies also incorporates things such as electronics and robotics, and it's part of the larger technologies strand in our subject, which also covers topics such as food sciences and textile designs, creating things with woodwork and metalwork. It's kind of classified with those ones. And at the moment, things are changing a lot in our curriculum to move it a bit more towards the computational thinking side and incorporate more of that as well. So before I get into the curriculum, a lot of this has been talked about today, but I wanted to go over it just again because these are some things we're talking a lot with our politicians and with parents and with schools in New Zealand because there is still confusion among the public and among some others about why we should be teaching this and why we should have it in schools. So the key reasons we see are we live in a digital world now, so all students need to know something about digital technologies. One of the misconceptions is that we're teaching students these because we want them all to become computer scientists or software engineers. And it's not true, but we say we all live in a physical world. So we learn things like physics and biology at school. It's not because all students are going to become physicists, but it's because they need to learn about the world around them so they can be an informed citizen in the world. And that's why we want all students to be learning about digital technologies, because they live in a digital world. The other part is software has become present in every industry and career path out there. So again, having a basic knowledge of digital technologies has become a necessity for working in our world. The other motivators in particular are to do with the software industry, one of the biggest ones being that the software industry has a problem with diversity. At the moment, in most countries, not all, but in most countries, it is quite male-dominated. In some countries, there is also an issue with a lack of cultural or ethnic diversity. There's a lack of people with disabilities in the industry. And we really want to get more people into this industry because everyone uses technology, so all kinds of people should be involved in developing it. And when we get it into schools, we get more students exposed to it and aware of the field and its opportunities. And we want our next generation to be able to be creators of technology, not just users. And that's really one of the big goals with our curriculum in New Zealand. So, the current digital technologies curriculum in New Zealand, we were one of the earlier countries to start introducing this to our curriculum. We first introduced it in 2011. And currently in New Zealand, and as it was introduced then, it is a subject which has actually only got papers for the final 3 years of school. So, about 15-year-olds and up. And it's also currently optional. So at first we didn't have many schools taking up this subject. It was brand new. Teachers weren't really sure how to teach it. And it was optional, so there wasn't a massive push for that. But some schools did take it up and have really begun to succeed with it, and each year we're having more and more schools adopting it, and now it's really become quite a strong movement in our education system. There's a lot of teachers who are very dedicated to this and want it to be in all schools like we do. So before I get into the specifics of the curriculum, I wanted to show you a quick video of one of the outcomes for a student who'd done this in schools. One of the big aims in our technologies curriculum is to integrate a bunch of knowledge to create something, to solve a problem, or to create something that you want to use that makes the world better for you. So I've got a short video of a final year student's project of creating a small toy that he really liked. So could I have the first video, please? So this is a student who, I'm not sure if you have it. Ooh, could I have the volume down a little bit, please? Thank you. So I'm not sure what it would be called overseas, but in New Zealand we call it a hacky sack, and you juggle it with your feet and your shoulders, and it's a little ball. And he wanted to create one that would count how many times he was doing it, so him and his friends could have competitions. So it incorporated a lot of different skills from different technologies, such as materials technologies, with creating the outer environment. It also included robotics, it included modeling, it included programming and electronics. So that's one of our big goals, is to really have students see the application of this technology. That's good for the video. Thank you. So we want students to be able to see the application for it and things they can do with it, and to try and integrate their knowledge. So some of the things that are in digital technologies at the moment, we have specific papers or assessments on programming and software engineering. One of the biggest emphasis with this is teamwork, working as teams, developing it together, and understanding what kind of problem you want to solve, using computational thinking skills to take your goal, your problem, breaking it down and working together to create your solution. It's not all just on the computer. We also have students working with unplugged programming skills, where these students here are designing first the interface and then also creating the unplugged version of the code on paper, and may go on to implement it later. So programming and actually getting into coding and software design is one part of the current digital technologies curriculum. And there are also other parts of it which these skills then build onto. There's an animation side for the papers. And there's also quite a lot of electronics and robotics going on, so students can get quite hands-on developing things and 3D printing them, creating their own circuits. Quite similar to the great fashion show we saw of students' product creations earlier today. The other side to the current digital technologies curriculum is the computer science side. It's not just programming. The computer science side covers different things, different years. It's things like algorithms, software engineering practices, data representation, the kind of things that really come into computational thinking. And to give you a quick look at the kind of thing it looks like in the classrooms in New Zealand, at our university we developed something called the Computer Science Field Guide, which is an online textbook which gives students hands-on ways of learning about these topics. It explains them and also gives them projects to do in class. And each chapter also has a little video with an overview of the subject. So I thought I'd show you a quick one of these as well. Go to the second video, please.
Computer graphics is used to create all sorts of images. But at the end of the day, they're just pixels that are being given a certain color value. Computer scientists who work with computer graphics work out how to take an object, do some calculations and translate that to a computer screen. For example, we need to think about an object's rotation. its position in 3D space, and its size. This also involves specifying colors mathematically and working out what objects should appear in front of and how to add shadows and reflections. Even working out which pixels to use to draw a circle or a line isn't that simple. In this chapter, we're going to look at some of the challenges and some of the calculations needed to get the right pixels in the right places on the screen.
Thanks. So, play that to give you a little overview of the kind of concepts that we want to teach. Apologies if that wasn't coming through in the translation because I only just managed to get permission to use the video, so sorry about that. So this is our curriculum at the moment, and some schools have used it and done incredible things. They've really excelled, and their students are really loving it and creating amazing things. However, this isn't the majority of our schools because it's an optional subject and there hasn't been a huge amount of teacher training for that particular subject. The majority of schools, teachers haven't adopted it or haven't been able to really do it in a way that can be really successful for their students. So in 2014, our Ministry of Education began a review of this curriculum because it was becoming clear, of course, from so many other countries looking at it and from all we know about computational thinking, that this curriculum really needed to evolve so it was actually benefiting all students. And a lot of schools were already extending these topics into lower year levels because they'd begun to see the value. So after this review, it has recently been announced that this subject will now be expanded until from every year in school. It's going to be taught from the very first year of school until the end, and this is intended to be implemented by 2018. So currently we're working really hard to get this curriculum fully together. We have initial design, and we're also working hard to upskill teachers and figure out what we actually want it to look like in the classroom. And this is what our research group has been working a lot on. We have been working to create an outline of the curriculum based on what we already had, what was succeeding, and what other countries around the world were doing. And we've proposed this to the ministry, and currently this is forming the basis of the new curriculum. Specifically, these subjects down the bottom, these were already kind of present in other aspects of our curriculum. And of the top ones, algorithms and programming were in digital technologies, but only at those final 3 years. So now we're intending to have all of these implemented from 5-year-olds all the way through so that all students can be exposed to these things. So in order to make this happen and actually help teachers and get it into schools and get students able to do this, we've been working with a large group of primary school teachers in Christchurch. This is work that's being done by my research group, particularly me and Tim Bell, who's the head of our research group. We're working with about 50 teachers now, and they're all teaching about 5 to 12-year-olds, and we're getting them to try out this curriculum and try out these computer science, programming, and computational thinking activities and see what happens. So, what have we used with them? The resources and teaching tools that we've been using to actually get it going in the classroom are CS Unplugged. We've been using this extensively. Tim Bell, the head of our research group, developed these quite a few years ago. I think he tells people it's hundreds of years ago now, and it's spread everywhere. We've been using CS Unplugged a lot with all the year groups, particularly for teaching algorithms and data representation. And we've had a lot of success, and teachers have really enjoyed being able to do physical activities with their students rather than sitting in front of the computer. The other side to it, which we've now also managed to make unplugged, is programming. We've been doing this with the youngest kids, sort of 5 to 10-year-olds. We've been doing it with things called bee-bots, they're tiny, sorry, you can't really see them well, little bumblebee things. They're kind of like the turtle instructions that were being talked about earlier, and something that we have decided to call kidbots, which is basically one of the students is a computer, and the other student is the program they give to them. So we've been working with kids a lot to do this. We've also been doing block-based programming, things like Scratch. And so far, we've found it's incredibly successful in primary schools. We've already heard some anecdotes from earlier of 5-year-olds coming home and parents just being amazed by what we're doing, by what they can do and how enthusiastic they are. And we've been finding that as well. We've been finding that students are engaged in these activities. They really enjoy them. These are a small collection of the feedback we've had from teachers saying that the children were really engaged and enthusiastic. They found it fun. They loved writing their name in binary. These are coming up over and over again, that students really love this, and then find that they can apply it to other subjects. This has been brought up a couple of times today, which is really exciting because it helps show us in our study that it's seen around the world in different curriculums, which is the cross-curricular learning, being able to take what they learn in digital technologies and apply it to another subject. Particularly, we've been having teachers almost constantly incorporate it with physical education, which is not something we would have expected at first. Computer science people would generally not associate with it, but it turns out they go together really well. We've been in primary school in particular. It's really important and really great that this cross-curricular learning has been so successful, because in primary school, all learning is done in a cross-curricular way. All subjects are taught sort of at the same time, and there's a lot of subjects to get through. This is something our teachers have been struggling with, is there's a lot in the primary school curriculum already, and there's not a lot of time to teach it all. So we've been working with them to try and show them that actually they can integrate it with other subjects, and it makes teaching maths easier and more fun for the students. We had a teacher the first year, we did this project with her, who said that she will never teach geometry without using Scratch programming again, because it was the first time she'd had all her students love doing maths. And it's just been really incredible seeing this engagement in students and the change in them. And something that also is continuously coming up is how much it supports teamwork and social skills. So in one of our typical classrooms now, students aren't sitting at their desks on their computers or sitting separately working on a sheet of paper. They're working in groups, they're calling out to friends, they're cheering each other, they're creating solutions together, and it's really amazing to see. And something that has also been coming up is that students who were struggling with the education system have been doing really well. The wonderful story we just heard before, it was really exciting to hear because it sounded a lot like some of the things we've been seeing, where a student will be struggling with the way the education system works. They're there and either it's not suited to their learning style, or in other cases, the student doesn't want to learn because they've had bad experiences, or as some teachers would say, they're troublemaker students or they're difficult students. And we keep hearing that it's these students who do amazing in this subject. It's one of these things that it looks like it was missing for these students before. And suddenly they find this subject and they realize, I can do that. That fits my way of thinking. I can actually do this subject. And it's happened really consistently, and it's really wonderful to see these students who seem to have nothing really in the curriculum before find something. And many of them have then gone on to improve their social skills by teaching other students in their classes. One of the crucial things that we've found and has also been talked about in terms of the UK and the American curriculum and the Korean curriculum is that teachers need to be supported to do this in classes. Computer science and programming aren't traditionally topics that have been taught. That's why we're working on these new curriculums. So a lot of teachers, the vast majority of teachers, don't have experience with these subjects. And we've found in New Zealand that when you don't provide them with extra support, with training, with a community of other teachers to talk with really good resources, when they don't have that, they're afraid or they don't want to try these things. They don't want to risk trying out this subject. When you give them those resources, though, they rapidly gain confidence. They really enjoy it, and their students really enjoy it. I just wanted to share some pictures with you of the successes we've had with students doing the unplugged binary numbers. These students here are working at a competition we called the Mashup, which was they all came together and had one day to settle on a problem, create a solution, and prototype it. And the winner, I think, had come up with an idea for a teddy bear nightlight that you hugged and it helped you. It really reminded me of the robot that was talked about earlier with the little teddy bear and the lights. It was really nice. And then we also had lots of students working with B-bots. We've been doing this a lot with the youngest students, and they do it to help them learn the alphabet and learn other things. So really, in conclusion, in New Zealand, we've found that once this is in the curriculum, you have to offer support. We're hoping that once it's compulsory, there will be a decent amount of funding and a decent amount of support for it, so all our teachers can upskill in it and really do it in their classes. We've had a lot of success so far, but only with those teachers who have received that particular support. Digital technologies in New Zealand, it's been off to a great start, but now we're really working to take it to the next level. Been learning a lot from people here about what they're doing, which is really exciting. And something that all the students in here who may be starting this or maybe haven't tried it yet, and it's something we try to tell our students and our teachers all the time, is don't be afraid to try these things out. They are really fun. Anyone can learn them. It's not true that some people can be programmers and some people can't. It's something that everyone should try. And teachers out there who may be hesitant to try, the thing is you already know about 90% of what you need to know to be able to teach this because you're teachers. What we want to do is provide those extra resources to get teachers the rest of the way there. Thank you.